let's look at a couple other examples. We're going to do lots of backtracking this week, so let's do another one. Let me open up my slides for today. Backtracking 2. Here we go. So this is just a remember the choose, explore, unchoose kind of thing slide. You guys already have seen that. So let's look at a new problem. Let's take a string and produce all the permutations, all the rearrangements of the letters in that string. So of course I'm selfish, self-centered, so I chose my own name as the string in question. Turns out if you rearrange the letters in my name, one of the combinations you get is my rat, I guess. Whatever. If you take Marty Stepp, like my first and last name, and you rearrange it, one of the rearrangements is sperm patty. I don't know what that is. I think they might sell those at the student union. I don't know. Cut that from the SCPD video. No. Anyway, rearrange the letters of a string. OK, how is this a backtracking problem? Well, you know, when we think about recursion, we think about base cases and calling ourselves and all of that. But when we think in particular, when we think about backtracking problems, we think about choices, choosing, exploring, and unchoosing. And for any backtracking problem, the challenge becomes, how do I express this as a series of choices? What are the choices and who makes them and how much does each call do? How much of the work is done by each call? You know what I mean? And once you kind of get the hang of these problems, once you look at a new one, usually you can kind of figure out what the unit of work is. Each call is going to handle this much of the overall task, but it takes a while to get that instinct. When you look at this problem, what do the choices look like to you? Like one call makes a choice. What choice does it make, and what part does it pass on to the next set of calls? What do you think? Somebody who hasn't helped me yet today, maybe? In the back, yeah.
Chooses the first letter, and then makes the first choice.
Choose a letter. I'll go with the M first. I'll go with the R first. Sure. And then, of course, you're always thinking, like, what could follow that choice? Well, if I start with R, what rearrangements could come after that? And if you're on the right track, usually you will figure some self-similarity where, like, if I pick the R, I want to print that R followed by all the permutations of M-A-T-Y, right? Matey, R matey. That's another one, right? Where is that in the arrangement? There's an R matey in here somewhere. Where? I can't see it anyway. First up there, no? The very first one, R matey. Yeah, that's great. Did you know my birthday is September 19th, which is Talk Like a Pirate Day? OK, I guess you don't care. No one cares about that. I didn't know there was such a thing as Talk Like a Pirate Day, except that then people started coming up to me on my birthday, and they would be like, "Army matey," and I was like, "What are you talking?" I thought it was some kind of birthday joke, but it had nothing to do with me. Anyway, OK, we want to choose a letter, and we want to leave the remaining choices of letters to be done by the later calls. OK, so what? So here's a decision tree. I picked to do the M first, and now we'll explore all the combinations that can follow that. I'll choose the MA, I'll choose the MR, I'll choose the MT, I'll choose the MY. I'll choose to follow the MA with the R, I'll choose to follow the MA with the T, I'll choose to, right? This is the kind of a tree that our code is going to try to walk. And of course, once we get to the bottom, we will have arranged all of them, and there'll be nothing left available to be chosen, and that's where we're done, and we can print what we've built so far, right? OK, I've got a Socrative here, but I'm going to skip it. I'm going to do one of the later Socratives instead of this one. Basically, the Socrative question is asking something about how do we keep track of our choices? And I think I'll still pose you that question, but I just want to discuss as a group here. So choose a character, permute the rest, and unchoose the character. That's kind of what we're thinking. How do I remember the characters that I've chosen? How would you choose to remember that if you were coding this? Any ideas? It might be one of these choices. What would you do? Oh, you're going to make me do it, aren't you? You're going to, OK, fine, fine. I'll make you vote. Fine. You won't raise your hand, I'll make you vote. OK, this is what happens. I saw you, Indira. I'll call you next time. OK, let's do multiple choice. Which one do you think it is? Vote. Go. If you think it's none of the above, vote E. You talk to your buddy if you want. Go ahead and vote if you haven't voted yet. I'll give you a few more seconds to decide. I can see the results here. You know, it shows me what you guys are voting for. So, and of course, I always ask my fiance what she thinks. Do you want to know what she voted for? She thinks it's C, but she doesn't even know what the question is. So that's neither a positive nor a negative indicator. You guys think it's everything. Wow, cool. I really admire the 3% of you who chose E, which was not one of the options, but that's cool. Thanks for being here. But a lot of people liked all these different choices. OK, so that's good. It means we should talk about it some more, right? Now, remember when we did the dice sum, we passed along a vector of all the choices that we had made along the way, of all the dice rolls, vector of ints. You could do something like that here. You could make a vector of the characters you chose, like a vector of char, or a vector of strings where all the strings are one letter, something like that. That would be fine. So I would say if you chose D, like vector, that would be fine. That's nothing wrong. So D is not a wrong answer, I would say. It's not what I would choose. I would choose a string. I would have done C. So I guess actually Mariana is correct. She's so brilliant. She doesn't even need to know what the question is. That's why I love her. That's why I love her. I would choose to store my choices in a string. Just the reason for that is because it's pretty easy to use that because you just have a string that starts out empty, and as you choose a letter, you just concatenate it onto the end of the string. For this particular problem, that works out pretty well. You could do a vector, but you know, it's no better. I think the string is slightly simpler to use. Let's try to code this real quick together. So I've got a file here. Let's see. I think I need to open the other file. Where is it? Backtracking to. OK. Source. Permute. OK, so I'm going to permute Marty like it showed on the slide. And we'll jump down here. There's permute. Wait, vector. No, that ain't right. Permute string is what I want. So yeah, I want that. OK, permute a string. Now, what we usually do is we write a helper that adds in more parameters, right? So let's make void permute helper that takes string s and passes along what we've chosen so far. And if you look at the picture of the tree of calls, it's kind of like what's chosen is the one string and what's available is s, basically. OK? So why don't I say string chosen? This is all the letters that have been chosen. This is where we'll do the real work. And this function we were asked to write, we'll just call the helper, get the helper started. I think of the helper as like the TA, and this is like the teacher. And the teacher doesn't do anything except give work to the TA. Sorry, Kevin. It's just how it is. So all permute is going to do is call permute helper and pass s, and what is initially chosen? Nothing, right? An empty string. So that'll do. And now in here is where we'll do the real work. So we still have the if-else for the base case versus the recursive case. But within the recursive case is where we do the choose, explore, unchoose stuff. You don't need to do that if there's nothing to do. So what would be a base case here? Any ideas? Like what's an easy string to permute or something where we don't need to do really much work? Oh, you guys are getting good. You said empty string. I bet a lot of people were thinking or even said a single letter because you just print it, right? And you're right. That is very simple. But you have to be really lazy when you do recursion. It's even simpler to permute nothing. Nothing. Permuting nothing is even easier than permuting one thing, right? So like, what if I said if S is empty, empty is the method for asking whether a string has no characters. I could have asked if it equals quote, quote. That would be fine. If it's empty, then what does that mean? Well, it doesn't mean that the string started out empty. It just means that as we went along this call tree, we've been whittling it down until it was nothing. And that means that hopefully our chosen string has been growing and now holds something in it. So what should we do if the string S is empty? I should print the things that I have chosen up to this point. Yes. So cout chosen endl. OK, good. Otherwise, there's at least one character of S that we need to, now we need to do the whole choose, explore, unchoose. Right? And so what does that really mean here? Well, we are supposed to do one letter. We're supposed to try all the possible letters that could come next. So like, I think the way of thinking of this is like, think about, there's many calls, and I'm in the middle of that process. There were some calls before me, and there's going to be some calls after me. Think of it that way. So chosen has some letters that somebody else picked first, and now there's like 3 or 4 letters left in S. And what I want to do is, each of those letters, I want to pick that, and then explore what could come after, and then come back and unpick that, and then try the next one and repeat. That's what I'm going to do, OK? So in order to enumerate all the things that I'm going to choose, explore, and unchoose, that's a place where potentially you can have a loop here if you want one. And that would be looping over the letters of S, because it's like for each of those letters, I'm going to try that one being the next one. OK? So for each letter, I is less than s.length, I will choose that letter. How do I choose it? Well, I will pull it out as like a variable or something. Char c equals s bracket I, that character out of the string. OK. I will explore what could come after that. So I'm going to call myself, right? That's usually explore means recursive call. So I'll call permute helper, and I'll pass what? I don't usually pass exactly the same parameters. I have to pass slightly different state to the next call, right? What would you pass?
You want to pass S with the current character removed, and you want to pass chosen with the current character added.
Right, so I want to pull the character C out of S, and I want to put it into the end of chosen. Totally, that's exactly what I want to do. So chosen plus equals C, put that at the end of chosen. And I got to remove it from S. So S equals S dot substring, something like that. There's a method that strings have in C++. You can just say S dot erase, and that just like deletes letters from a string. Let's see, what do you say? You say at index I want to erase one character. I think that's how you say it. And that'll just throw that out for now. And now I'll call the permute helper with the new value of S and the new value of chosen. OK, that's explore. And then when you get back, you're supposed to unchoose, undo. So I have chosen this, and I modified my variables to explore what would happen after that. Now I want to put it back the way it was before. So I think that means s.insert at index I, one character, which is C. I think that's the way you say that in C++. And then I want to delete the last character from chosen. So chosen.erase the last character of it, which is chosen.length -1, I think. Oh, and erase one character from that spot. OK? What will happen? Whoa, look, it did things. Now, I could imagine that this piece of code would be hard to write for a lot of us, just write, from scratch. Like, I kind of moved quickly there. But this is the typical pattern, is figuring out, OK, what are the choices here? The choices are individual letters. For each of the letters that could come next, I'm going to choose that. You're just figuring out the arrangement here is the hardest part, I think. Some of these details about, oh, what's the name of the method to move stuff in a string or whatever, this is just kind of mechanical detail kind of stuff. The really hard part is figuring out how to shape this code properly. And I think a lot of people make mistakes like they don't unchoose here, okay? Like, oops, they don't realize they need to do that. What would the code do? Why do we need to do the unchoosing? Why is that so important? Well, let's take it out and run it again. What happens? That's it. Why did it do that? Well, I think the way of thinking of it is basically that it's never going to go back and put the letters back in there, so it's going to have a limited path of exploration. So, I mean, again, the thing I always like to do is do cout permute helper plus s plus comma plus chosen. End all. And like a lot of times if I'm printing strings, I like to put little inserted quotes around them like this so I can see. Sometimes it's hard for me to see where the strings begin and end without little quotes around them. So if I run this again, here's what I see. Permute helper, Marty nothing, Arty with an M, Erty with a ma, T with a mar, Y with a mart, and nothing with a Marty. Hey, I got down to the point where S was nothing, so I printed Marty. Now I'm supposed to backtrack. What I'm going to backtrack and undo is the last choice. So now it does T with Mary. Anyway, this is a broken version of the code, but I'm going to put it back where it does unchoose. But again, I think that inserting a print statement at the start of your program is a good way to do this. And if you want indentation, like I think it's easier to see these when they're indented. And I would do something like, if you want this indented, like what if we had a method called like void indent, and you pass me int n, and I'll indent by that many tabs. So I'd say like for int I equals 0, I less than n, I plus plus, and then I'll do cout space, 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 space. Okay, so just indent by n tabs worth of amount. Then here I could do something like indent by chosen dot length. So the more stuff I've chosen, the more indented it'll be. And then print this permute helper. Now check this out. Boom. Looks pretty cool, huh? So does that look a little better? Like permute helper with Marty nothing calls Arty M, and it goes down. I think people get it like down to the bottom where you get Marty, but then the kind of unwinding and then T with Mary, you know, that's me unchoosing the Y as the last letter and picking now the T to be the last letter. It's just, you know, you can watch the calls and see the order that things are happening with something like this where you print them out. And I think the indentation helps me a lot. Because if it's all indented, all of the stuff that's indented at this level is underneath that original call of permute helper RDM. Like, all these calls are under that. This is RDM, but I chose the R as the second one. You know what I mean? So, anyway, question, yeah?
What if the input string has repeated characters? How do we eliminate the repeated?
That's a great question. What if the input has a letter more than once? What if I'm permuting Google? And let me comment this out for a second, all the indentation stuff. I'll compile it and run it. And what do I get? I get a bunch of strings, but I think what you're asking about is that I'm going to have repeats here. Like, let's see. So here's eglogo, and a couple down I have eglogo. Do you understand why that's twice in the output? Why is that twice in the output? Does the code have a bug? Yes, sir? Okay, great.
The two O's, they are considered different.
Right, there are two O's in the word, and it's choosing one of the O's and exploring, and then later it's choosing the other O and exploring. And the end result looks like two of the same output to us. Right. Is there a rearrangement here that's like Lego? Look, Lego OG. That's like if you've been into Legos since the old days, you know, you're a Lego OG, you know. Never mind. Never mind. But anyway, I consider myself a Lego OG, actually. Right. So if we wanted not to print the same thing twice, how could we accomplish that? What would you do? Somebody maybe who hasn't been called yet. Yeah.
I would create a set where you can add all of the words that you're printing out and then just check if it's in the set before you print it out.
That's a great answer, yeah. And maybe that's what you were going to say also. So if you wanted to only print the words once and not print the same word twice, then I would add something like set of strings that have been already printed. And then here, when I print chosen, I would say already printed dot add what you've chosen. And I do something like, if it's not already printed. If already printed doesn't contain this set of chosen letters, then I will print it. Understand? So there. And now up when I do the permute helper, the permute helper gets called by permute. Where is that? Here. So I would have to say set of strings chosen, which is empty, and I'll pass chosen to start things off. So yeah, I think that will do it, right? Oops, too few. Oh, I think I have that mistake again where my prototype doesn't have, wait, do I not have a prototype? Wait, what's the problem? Too few arguments. Oh, when I call the helper from itself, when I do the recursive call, I have to pass already printed down to the next call as well. Okay. So now, when I run this, wasn't this printed twice before? Eglogo. I don't see it. I don't know. I think we fixed it, basically. I don't want to sit there and hand verify it, but it looks like it's fixed now, that particular issue. Yeah?
Would a more efficient way to do that be to not explore the letters that we've already chosen to?
So maybe keeping all the prefixes. Like if I've picked these 3 or 4 letters as a starting point before, sure, you could definitely do it that way. So maybe that would be like putting things in already printed kind of earlier. Yeah, absolutely. So, I want to just kind of stop that line of exploration for now, but these are good optimizations that you could make in terms of not printing the same line more than once. It's a good way of solving that problem. Passing along a collection is a frequently used trick that we will do a lot with backtracking. Okay.